There is a plant that doubles its mass every 48 hours. Not in sterile laboratories, not under artificial lights. In any container of still water you leave outside your door. A single handful today becomes 2 handfuls by Wednesday, 4 handfuls by Friday. By the end of next week, enough to fill a bathtub. By day 30, you have harvested over 1,000 pounds of biomass from a backyard pond. This is not science fiction. This is mathematics. Exponential growth so aggressive that researchers have measured it, documented it, and confirmed it produces the fastest biomass accumulation of any plant species ever studied. But speed is not what makes this plant revolutionary. This plant contains 45% protein by dry weight. Compare that to eggs at 12%, beef at 26%, chicken at 31%. This tiny aquatic plant outperforms every animal protein source humans consume. And this is not incomplete protein, not the kind found in beans that requires careful combination with grains to become usable. This is complete protein. All 9 essential amino acids, in ratios that match precisely what the human body requires for tissue repair, immune function, and cellular regeneration. 1 square meter of water surface, 30 days of passive growth. Enough protein to sustain a human being for an entire month. No soil required. No fertilizer purchased. No tractors manufactured. No irrigation systems installed. No pesticides applied. No labor beyond simple harvesting. Just water, sunlight, and patience. The scientific name is lemna. The common name is duckweed. That green film covering ponds and slow-moving waterways. That layer of vegetation you have been conditioned to find disgusting. That is not contamination. That is the most efficient protein production system humanity has ever discovered. 1 acre of duckweed surface generates 10 times more protein than 1 acre of soybeans. 20 times more than 1 acre of corn. More food, faster, from less space, than any agricultural system in recorded history. But there is something else, something that should have made this plant the foundation of global food security decades ago. It purifies water while it grows. Duckweed absorbs nitrogen from contaminated sources. It extracts phosphorus from agricultural runoff. It captures heavy metals that would otherwise poison drinking supplies. It takes the pollution created by industrial farming and transforms it into edible nutrition. The plant cleans your water and feeds you simultaneously. An organism that grows anywhere water collects. That requires 0 purchased inputs. That produces complete protein faster than any crop ever cultivated. That removes toxins from the environment as a natural byproduct of its existence. This should be growing in every backyard garden, every apartment balcony, every community center, every refugee settlement. Every neighborhood where families struggle to afford adequate nutrition. Instead, commercial cultivation is effectively prohibited throughout most of the developed world. Regulatory agencies classify it as invasive. Municipal codes define it as a nuisance requiring eradication. Environmental departments have allocated substantial resources ensuring you never discover its true potential. Welcome to Clean Eating Forgotten. The archive opens 4,000 years ago in the river deltas of mainland Southeast Asia. The monsoon rains have ended, the floodwaters are receding from the paddies, and floating on the surface of every pond, every irrigation channel, every depression holding water, spreads a carpet of brilliant green. The farmers do not drain it away, they do not consider it contamination, they harvest it. In what is now Thailand, they call it phoom. In Myanmar, ye cane. In the river valleys of Laos and Cambodia, it has been collected from rice paddies since before any written language existed to record the practice. Picture a village in the Mekong Delta, approximately 2,000 years before European contact. The morning sun rises over flooded fields. A woman wades into knee-deep water carrying a woven basket with a fine mesh bottom. She skims the surface with practiced movements. The green material accumulates in her basket, draining water back into the paddy. The texture is soft, almost silky. The color is vibrant, the deep green of concentrated chlorophyll. The smell is clean, vegetal, like fresh grass after rain. She carries her harvest back to the cooking area. Some will be dried on flat stones, ground into powder, stored in ceramic vessels for months. Some will be mixed directly into the fish soup simmering over coals. Some will be fed to the ducks that give this plant its English name. This is not desperation food. This is not famine survival. This is a cornerstone of nutritional abundance for civilizations that flourished for millennia. The practice evolved into something remarkable. Integrated systems emerged organically from generations of observation. Rice paddies grew duckweed on their surface waters. Fish lived beneath, consuming excess vegetation and converting it to animal protein. Ducks and chickens ate harvested material from the pond edges. Pigs consumed what the poultry left behind. The waste from all these animals returned to the water as fertilizer. The duckweed cleaned it again. Zero external inputs. Complete nutritional cycles. Protein systems that sustain themselves indefinitely without purchased seeds, manufactured chemicals, or depleting the land. Travel northeast to the agricultural heartland of ancient China. Documents from the Han Dynasty, approximately 200 years before the Common Era, describe pond management techniques that prioritize duckweed cultivation. Scholars observed that water bodies with thick duckweed coverage produced healthier fish. They noticed that rice paddies with floating vegetation required less added fertilizer. They documented that livestock consuming this plant grew larger and stronger than animals fed conventional fodder. They did not understand nitrogen fixation. They could not measure amino acid profiles. They had no concept of protein bioavailability. What they understood was outcomes. What they recorded was results that repeated across centuries of practice. The integration became sophisticated. Pond systems were designed with specific depths and sun exposures to optimize growth. Harvesting schedules were refined through generations of experience. Storage and preservation techniques developed to extend availability through winter months. When European expeditions reached Asia beginning in the 15th century, the explorers documented these practices with considerable astonishment. A Portuguese missionary traveling through the region in 1590 wrote extensively about villages that produced abundant meat without requiring grazing pastures. He struggled to comprehend how concentrated protein appeared seemingly from nothing more than shallow water and sunlight. The agricultural systems he witnessed contradicted everything European farming had established about the resources required for food production. The knowledge was comprehensive. The systems were proven. Hundreds of millions of people across the most densely populated region on Earth depended on these integrated methods. Then colonization transformed the landscape. European agricultural models did not accommodate pond cultivation. They did not recognize integrated aquatic systems as legitimate farming. Colonial administrations imposed frameworks of land ownership, monoculture cropping, and dependence on purchased inputs. Traditional wetlands were drained for conventional agriculture. Integrated systems were dismantled in favor of export commodities. Administrative classifications labeled duckweed cultivation as primitive, backwards, inappropriate for modernizing societies. Within 2 generations, knowledge that had sustained civilizations began fragmenting, but not completely. In Bangladesh, communities too impoverished to adopt industrial methods continued traditional practices out of necessity. In remote villages of Myanmar, families maintained backyard ponds because they had no alternative. Along the Mekong Delta, elderly practitioners remembered techniques their grandchildren were never taught. The wisdom survived in margins. Among populations too poor for agricultural modernization to reach. Among communities too isolated for development programs to transform, they continued cultivating the fastest protein source on Earth, while the rest of the world learned to classify it as unwanted growth requiring elimination. Modern scientific validation came through an unexpected channel. In 1985, aerospace researchers were searching for the ideal crop to sustain long-duration space missions. The requirements were extreme. The plant needed to grow rapidly in severely confined spaces. It needed to produce complete nutrition without soil or extensive infrastructure. It needed to recycle wastewater from the crew habitat. It needed to generate oxygen while consuming carbon dioxide. Duckweed satisfied every criterion. The research findings appeared in peer-reviewed aerospace publications. The measurements shocked even the scientists who conducted them. Protein content registered at 45% of dry weight. Growth rates confirmed doubling times under 50 hours. Water purification efficiency reached 99% nitrogen removal in optimal conditions. No other candidate species approached these performance levels. Follow-up analysis at a major aerospace research facility calculated theoretical yield potential. 1 hectare of duckweed surface could generate 140 metric tons of dry protein annually. For comparison, soybeans produce less than 1 metric ton per hectare per year under ideal conditions. The efficiency differential was not marginal, it was transformational. More than 100 times greater protein production from equivalent surface area. Nutritional analysis at a prominent agricultural research university examined the amino acid composition in detail. Results were published in a leading food chemistry journal in 2009. Duckweed protein matched international nutritional requirements for human consumption almost exactly. Every essential amino acid was present in adequate quantities. The limiting factor, methionine, still exceeded minimum thresholds established by global health authorities. This was not livestock feed quality. This was human food quality. Complete nutrition suitable for direct consumption. Researchers in Germany conducted controlled human feeding trials. Study participants consumed duckweed preparations over extended periods. Digestibility measured at 93%, comparable to premium animal proteins like eggs. Bioavailability showed efficient absorption and utilization. Taste evaluations described mild, slightly nutty flavors with pleasant texture. No adverse health effects were documented across any trial participants. The research paper, published in 2014, stated conclusions without qualification. The plant species is suitable for direct human consumption as a primary protein source. Water purification studies added another dimension entirely. Engineering researchers in Bangladesh demonstrated that duckweed systems could remove 95% of nitrogen and 70% of phosphorus from contaminated water sources. The plant did not simply tolerate pollution. It actively consumed pollutants as nutrient inputs for growth. A pilot project in the capital city processed municipal sewage through duckweed lagoons. Output water quality was suitable for agricultural irrigation. Harvested plant material was fed to commercial fish farms. The fish were sold in local markets. Waste became protein. The cost per kilogram of protein produced measured less than 10 cents in local currency. An international development organization funded a comprehensive review in 2019. Researchers analyzed 17 years of accumulated studies from 12 countries across 4 continents. The synthesis filled 40 pages of technical documentation, but could be summarized in one sentence. This plant represents the most resource-efficient protein source currently available to humanity. The scientific consensus was established. The data was overwhelming. The implications for global food security were revolutionary. So, why does this plant not appear on grocery shelves? Why is it absent from restaurant menus? Why have most people in developed nations never heard of it? The regulatory classification tells part of the story. In the United States, duckweed is categorized as an aquatic nuisance species across 37 states. Commercial cultivation requires extensive permits. Transportation across state boundaries can result in substantial fines. In some jurisdictions, possession of living specimens violates environmental codes. The stated justification is ecological protection. Duckweed spreads aggressively. Under favorable conditions, it can cover entire water bodies and block sunlight penetration. It can alter existing aquatic ecosystems through rapid proliferation. These statements are accurate. They are also true of essentially every successful crop species humans have ever cultivated. Wheat spreads aggressively when conditions favor it. Corn outcompetes native vegetation wherever it establishes. Soybean cultivation has converted hundreds of millions of acres of diverse ecosystems into uniform monoculture. Industrial agriculture has transformed approximately 1 billion acres of wilderness and traditional landscapes into single-crop farmland. This conversion continues annually. No regulatory agency has banned soybeans on ecological grounds, but duckweed faces different treatment. Duckweed does not require purchased seeds. The plant reproduces vegetatively, meaning any small portion can regenerate a complete population indefinitely. There are no seed patents, no annual purchases from agricultural corporations. Duckweed does not require manufactured fertilizer. It extracts nitrogen directly from water sources, including waste streams that would otherwise require expensive treatment. Duckweed does not require synthetic pesticides. The rapid growth rate and aquatic habitat provide natural protection from most agricultural pests. Duckweed does not require specialized machinery. Harvesting requires only simple tools available in any household. A functional duckweed cultivation system can be established with a plastic container and a handful of starter material collected from any pond. Total investment under $20. Ongoing costs effectively zero. That accessibility is precisely the problem. The global animal feed industry generates approximately $400 billion in annual revenue. Soy protein dominates that market. Corn supplements it. Both crops require substantial infrastructure. Both require annual seed purchases from consolidated suppliers. Both require chemical inputs manufactured by integrated corporations. Duckweed threatens this entire economic structure. It costs almost nothing to produce. It grows faster than distribution systems can justify. It makes the foundational business model of industrial feed production economically obsolete. The pattern extends to human nutrition markets. Protein supplements represent a market exceeding $20 billion annually. Protein powders, nutritional bars, performance shakes, all depend on complex processing and premium positioning. Duckweed powder costs less to manufacture than the packaging materials it would require. Environmental regulations provide convenient protection for established interests. Classifying duckweed as invasive makes commercial development practically impossible within regulatory frameworks. Permit requirements add costs and administrative obstacles that small producers cannot absorb. Startup companies attempting to enter this market face years of review processes before any commercial activity can begin. Meanwhile, the plant species capable of addressing global protein deficiency floats on ponds across the developed world. Classified as a nuisance, legally restricted from commercial development. The communities who could benefit most, smallholder farmers, food-insecure populations, developing regions without agricultural infrastructure. These are told the plant is too dangerous for cultivation. Too dangerous. A species consumed safely by human populations for 4,000 documented years. Too dangerous. A crop selected by aerospace researchers to sustain human life in the most demanding environment imaginable. Too dangerous. A protein source identified by international development institutions as the most efficient option available. The regulations are not protecting natural ecosystems. They are protecting revenue streams. And the cost is measured in expensive protein, depleted agricultural land, and contaminated water systems that duckweed could remediate. But the knowledge was never fully suppressed. In rural communities across Bangladesh, traditional cultivation persists. Families maintain backyard pond systems that produce protein continuously throughout the year. In Myanmar, practitioners who learned techniques from grandparents continue methods refined over generations. The knowledge transfers quietly, outside official channels, beyond regulatory reach. In the Mekong Delta, elderly farmers still remember integrated systems their ancestors perfected. Some have begun teaching younger generations who recognize the value conventional agriculture has failed to provide. And something unexpected is emerging. Across developed nations, small-scale growers are rediscovering what regulations tried to bury. Permaculture practitioners have integrated duckweed into closed-loop food systems. Urban farmers utilize it to supplement livestock feed while reducing input costs by half or more. Homesteaders in warm climates grow duckweed to feed fish that provide year-round protein for their families. Aquaponics designers incorporate it into waste processing loops that convert byproducts into nutrition. Functional medicine practitioners now recommend traditional protein sources to patients seeking alternatives to industrial food products. The knowledge is spreading through networks that bypass commercial channels entirely. In 2023, retail sales of whole food protein alternatives increased by over 30%. Meanwhile, sales of highly processed protein supplements declined for the first time in 2 decades. The market is communicating something important. Consumers are seeking options the industrial system cannot provide, because once you understand the mathematics, you cannot unknow them. 45% complete protein. Doubling time under 2 days. All essential amino acids in bioavailable form. 0 required inputs beyond water and sunlight. This is not a dietary supplement. This is a fundamental restructuring of how protein can be produced. Reclaiming this knowledge requires surprisingly little effort. The regulations restricting duckweed apply specifically to commercial operations and natural waterways. They do not govern closed containers on private residential property. A plastic storage container in your backyard is not a regulated waterway. A livestock watering tank on your property is not a commercial operation. A small pool on your apartment balcony does not fall under aquatic nuisance legislation. You can grow duckweed legally in virtually any location. The investment is minimal. The returns are substantial. Here is what the regulatory framework does not want you to understand. Step 1. Obtain starter material. Visit any pond or slow-moving waterway in warm weather. Collect a handful of the floating green vegetation. This provides sufficient genetic material to establish a permanent supply. Step 2. Prepare a growing container. Any waterproof vessel functions adequately. Plastic storage bins, retired bathtubs, children's wading pools, even large buckets provide suitable environments. Fill with water and position where it receives 4 to 6 hours of direct sunlight daily. Step 3. Introduce the starter culture. Spread the collected material across the water surface. Within 2 weeks, the coverage will expand dramatically. You will have more than you can utilize. Step 4. Establish a harvesting routine. Skim 1/3 to 1/2 of the surface coverage every 3 to 4 days. This maintains optimal growth density while providing continuous yield. Step 5. Process for storage. Spread harvested material on screens or clean fabric in direct sunlight. Once completely dried, grind into powder using any kitchen blender or food processor. Store in sealed containers away from moisture. Properly dried material remains nutritious for months. Step 6. Integrate into food systems. Dried powder can be added to smoothies, incorporated into baking, mixed into soups and sauces. Fresh material can be consumed directly in salads or as garnish. Both forms can be fed to poultry, which convert the protein into eggs with significantly elevated omega-3 content. Step 7. Expand your system. Once established, duckweed can process household gray water, extract nutrients from fish tank waste in aquaponics configurations, or convert nitrogen-rich runoff into food instead of allowing it to become pollution. 1 square meter of water surface produces over 1 kilogram of dry protein monthly. A system covering 10 square meters, roughly the size of a small bedroom, generates enough protein to significantly supplement a family's nutritional requirements year-round. The industrial food system has conditioned you to believe protein is expensive, that food production requires corporate infrastructure, that nutritional security depends on supply chains beyond your control. Duckweed demonstrates a different reality. Abundance without permission. Protein without corporate intermediaries. Food sovereignty in a container you can purchase for less than a restaurant meal. Every warm pond already contains the genetic material. Every water surface can support cultivation. The infrastructure exists everywhere, waiting for activation. The only missing element is knowledge. Now you possess it. A handful of green vegetation, a container of still water, 14 days of patience. That is the distance between your current situation and free protein production for the remainder of your life. The story of duckweed is not about one unusual plant species. It is about a system designed to maintain dependency, an economic structure that cannot profit from solutions requiring no purchased inputs, a regulatory framework that protects revenue over nutrition. For 4,000 years, human civilizations understood that abundant protein could grow from any body of still water. This understanding was systematically devalued, marginalized, and ultimately prohibited from commercial development. But prohibition is not elimination. The knowledge survived among those who needed it most. Among communities too practical to abandon methods that worked. Among practitioners too observant to accept artificial scarcity. That wisdom is not lost. It floats on the surface of every pond. It waits in every container of standing water. It requires only your attention to activate. The most efficient protein source ever discovered grows in ditches, while corporations market expensive alternatives. It cleans water while producing nutrition. It requires nothing while delivering everything. The industrial system calls it a nuisance. Traditional wisdom calls it a gift. The choice between those frameworks is yours. If this archive revealed something valuable, subscribe and activate notifications. Every interaction helps preserve knowledge that powerful interests prefer buried. The next archive opens soon.